279 perfect squares. This Java code defines a class solution which has a public method numSquares. This method determines the least number of perfect square numbers that sum up to the given integer n. Here's a step-by-step explanation of the numSquares method. 1. While n is divisible by 4, divide it by 4. This is a simplification step, as a perfect square divided by 4 is still a perfect square. For example, 2 to the 2 times k to the 2 equals 4k to the 2 equals k to the 2 plus k to the 2 plus k to the 2 plus k to the 2. So dividing by 4 doesn't change the number of squares needed. 2. Check if n modulo 8 is equal to 7, i.e. n modulo 8 equals 7. This is based on a mathematical theorem called Legendre's three-square theorem, which states that a natural number can be represented as the sum of three squares of integers, unless it is of the form 4 to the a 8b plus 7 for non-negative integers e and b. If this condition is met, the method immediately returns 4, indicating that the number cannot be expressed as the sum of three squares and must require 4. 3. A for loop is used to test whether n can be expressed as the sum of two squares, or a single square, which is a special case of two squares where one of the squares is 0. It iterates through all as such that a squared is less than or equal to n. Inside the loop, it calculates b as the square root of n, a times a. Then it checks if a times a plus b times b is equal to n. This is the condition for n being expressible as the sum of two squares. If such a pair of a and b is found, the method checks if both a and b are greater than 0. If so, the method returns 2, as both a and b contribute a non-zero square to the sum. If either a or b is 0, the method returns 1, because then n is a perfect square itself and can be expressed as a single square. 4. If none of the above conditions is met, the method returns 3 by default. This is based on the earlier step that filtered out the case where n requires 4 squares. It is a given that every positive integer can be represented as the sum of 4 or fewer square numbers. Lagrange's four-square theorem. So if it's not 1, 2, or 4, based on the checks above, it must be 3. In summary, the numSquares method uses mathematical theorems to minimize the number of calculations required to determine the smallest number of perfect squares needed to sum up to the given integer n.